Okay, so I just wanted to revisit this test case. It's the radial fan one, and and this is the fourth iteration of this particular analysis. And I redid it because it needed to have some finer mesh. So if you have a look at the mesh here, what I did was I did 6 cells between levels. So I started off at 2 and then increased it to 4 and then increased it to 6 because I just felt like it needed more fine mesh around the interface of the MRF zone. And I also added this refinement region, which you can't see it too well at the moment. Let's change it to pressure. Yeah, I did in this refinement region um, to capture the outflow from the device. And so that's basically it. So the final mesh that I've got for this case is just less than 2 million cells. So about 1.9 million. But it still runs fairly quickly on my laptop, just running in parallel on 4 processors. Um, so yeah, I'll just put that back to surface. So then yeah, we could see, you can actually see the flow, kind of like the wake coming out from each of these fan blades. And I think this solution is going to be the final one because I'm relatively happy with it now. But the main concern was the variation of the outflow. So I was monitoring the outflow here at a plane on the exit, and it was really quite variable. So I did in the extra mesh refinement and ran it for longer as well. I ran it for 2000 iterations. So now what I've got, if I monitor the out file, um, using GNU plot, this is what I'm looking at is the area weighted average of the velocity at the outflow. So when you start this simulation, for some reason, which I don't quite understand, it goes really high. So the velocity goes up to 95 and then it settles down. And so you can see that the solution is 90% done at about 700 iterations, but I just ran it for longer just to check that it was stable and see what it was doing. So if we zoom in on this, we can see that during the second thousand, from 1000 to 2000, it is varying, but it's not varying a huge amount. I think that is kind of like good enough for demonstration purposes. So we've got an average velocity at the outflow of the fan that is, it looks like it's about minus 4.5. So you've got a model where you can adjust the RPM and then get a corresponding mass flow rate through the device. I mean, I'm using simple foam, so it's not going to give you a mass flow rate directly, but from the velocity you can calculate what the mass flow rate would be. So that is okay. And then in terms of the residuals, I use PyFoam plot watcher on the output file. I concatenated the output files together because it was 2 separate runs. So then if I look at this one here, I don't know why the lines are so thin in this one, but again you can see that it's kind of converged as much as it's going to at about 700 iterations, and the rest is just basically to check that the solution is stable. It's not going to diverge or anything. It's not the best convergence, but I don't. Then again, it's not that bad. I think And maybe it's the nature of this type of problem that, the convergence is as good as it's going to get. I'm not entirely sure, but um, at least we are checking the convergence to check that it is a stable solution. And so yeah, if we go back to the flow solution, I can switch the fan on and off in that. So I've got the fan geometry loaded. And if I go back to this one, I can also do another slice and have a look at the velocity. Let's get rid of that big red circle. So if you want to have a look at it in the other plane, you can see how the device functions. So you've got the flow coming in from left to right. It's being sucked in, and then it's just increases its velocity as it sort of spins around the device, and then due to the centrifugal nature of this fan, the velocity is increased and then it's pushed out. The interesting thing about this type of problem is just how variable the velocity is at the outlet plane. So you've got the highest velocity is between 15 and 20 all on one side of the outlet, and then it's low velocity everywhere else. So that in itself is quite interesting. But so yeah, that is my brief overview of this test case. So I've done 4 CFD runs on this. I finally got something that I think is acceptable, and so this is just a quick review of that test case.